if we wanted to, still thinking about residuals and looking for outliers, then we'll talk about influential cases, and we'll have to come back to SPSS. But if we go back to our analysis for linear regression, and our dependent variable is how often they attend church, then we have our 6 independent variables. The approach that I'd recommend taking is just going to statistics, clicking case-wise diagnostics, and I guess it defaults to 3. And if I do 3, it won't print anything out for me, so I changed it to 2.5. If I did 2, it would print out way too much. You could do all cases, and then you'd get a row for everybody in your data set. So you just need to play around with this number a little bit to get it. So you're looking at the right. So you can see what's most extreme in your data. And they may not be extreme at all, but you need to figure out where that is. Another way you could do that, which might be equally as efficient, is just to go to Save. And if you remember earlier in this semester, we did the Multicollinearity. And sorry that you can't read that very well. And then up here it's residuals, and we just want to do standardized residual. You could do unstandardized, and then it's going to be exactly that. It'll just be the unstandardized. So I'll just ask for both of them. And we'll say OK. And then it's going to do our analysis for us like it always does. But at the end of our data set, the last 2 columns here will be our residual and the standardized residual. And what you could do then is you could, one way to look at residuals would be, I like visuals, and so we could just do a quick scatter plot. That would be, I think what I'd do is reset this. I think I would put case ID on the x-axis, which that's just their number in the data set. It only represents where they're at in the data set. And then I could do the unstandardized residual as on the y-axis. And I could just look, what I'd be looking for is, are there either on the, because it says either minus or positive, are there cases that there's a large separation between it and the rest of the data? In my case, I don't see anything that's particularly problematic. So let's say I had a point that was way up here, and then there's a big gap, and then we had the rest of the data. That point way up here should raise a red flag. Because there's such a gap between it and everybody else, you might want to go look at that person's data to see why they are unique. And so that brings up the question, well, how do you know who they are? If you double click on the graph, you can click on any of the cases. You can click on any one of the case. And then if you right click on the case, there's a thing down here that says show data label. And it gives you the case ID number. You can also right click on one of the cases and say go to case. And it will take you to that row of data in the data set, okay? So just another way to look at the residuals. In this case, we're just looking for residuals that are a large distance from where everybody else is. They're an outlier in that way. And so that's the way that we could use just in that case, I was just using the unstandardized residual. We could also do something with the standardized residual. What might we do with that? We could do descriptive statistics, and I think I might do descriptives. Does it give me min and max?
Yes.
So I could do standardized residual. And do I have any options here? Min and max. So I can do that. And I can see here that my the minimum is minus 2.89. The max is 2.94. And then I might drill down if I was really concerned about any one of the min or max. I could go look at those and see if there are any problems. You could do frequencies, but I think I'd worry a little bit about frequencies. There'd be too many of them, but let's just do that because that might, in this case, that might be a little bit better. So if we do frequencies of the standardized residual, yeah, I can see that I have one that's minus 2.89. That's the one that it surfaced. And then it drops to minus 2.66. And so this would be a way for me to look through these to see if I have any problems. Then I could look at the maxes. And I can see that the max is 2.94. And I could go find that case in the data. So let's say I did this. Let's say I want to find that case that was 2.94. The max, how would I find that? How would I go about finding that person? Because this doesn't tell us what the case number is. It just tells us the max is 2.94. What would you do?
Sorry, was that descriptive or frequency?
This is frequencies.
Okay, thanks. Sorry.
Descriptive just gave me the min and the max. And I'm saying for the max, how would I go about finding what ID number that is in the data set? What would be one way to do that? I don't think I can click on this and tell SPSS to tell me that.
Could you,
Yeah, it doesn't. What would you do?
the one that you ran first, can you just go sort them?
I like that idea. So we could go back here, go back. Sorry if you're getting dizzy. Go back here and look at our data. And this is the, if we looked at the standardized one, we could just sort this one. If we sorted it in descending order, we'd have the highest at the top. And then we could see what, we could go back and we could look at that person's data and say, well, what made that person such? And this is the person that probably said they go to church a lot and they never pray, or they could be the person who never prays and goes to church a lot, right? It's one of the two, I forget. And so this would be a way for us to look at our extreme. And then, of course, you could sort it in the other direction to look at the. I guess it sorts the. Is there an option to tell it not to do that? What's that?
I just said Siri.
Oh.
I thought you were actually asking, but like.
When it comes to the scatter plot, do you want us to have the standardized or the unstandardized?
I don't think I ask you to do scatter plots. You won't have to do scatter plots for looking at the residuals. And you could do standardized or unstandardized. It wouldn't matter. You would get the same picture. And so getting back to the homework, all you'd need to do is to do the case-wise diagnostics, find, do you need to set it at 2.5 or 3 or 2 to find where your sort of the mins and the maxes that you have, and then you can look at those cases to see if there's any problems. That's all you have to do for assessment of your outliers for the assignment. This is, what's that? This is second way. I don't ask you to do it 2 ways. This is bonus content. So that's outliers. Any questions about outliers? Questions about outliers? And so this is about where we left off. And so an outlier is not necessarily an influential observation. Most of the time they are, but sometimes not necessarily so. And so just by looking for outliers, we aren't necessarily finding influential cases. And an influential case is one that has a larger impact on the calculated values of the various estimates, for example, B and its standard error, when compared to other cases. And again, it's sort of it's a question that the researcher will have to answer for him or herself. Are you okay with some of the people if your unit of analysis is individuals, if some of the individuals in your data set having a larger impact on the estimates than others? And there's not a clear answer that I can give you there. In some cases, it would be clearer than others, I think. But in a lot of cases, it would require your judgment in terms of what you should do. And so what we're going to do is just a way to identify potential influential cases, and then you can make a determination from there. And so there's a number of ways to do this. The way that we're going to do it is we're going to use Cook's D for distance, and Cook being the person who came up with the statistic. And Cook's D identifies an influencer observation whose influence is due to its status on both the independent variables, the dependent variables, or both. If you think back to the Multicollinearity score that we calculated, when we looked for multivariate outliers, it only looks at the independent variable. It doesn't do anything with the dependent variable. Cook's D is looking at your independent variables, the dependent variable, and a combination thereof to see if any of your observations are influential in that way. And what we would do is that the value of the Cook's D is there'd be some things that we could do to make the value more meaningful, but what I would recommend doing is something similar to what we just did with the residuals. Just make a scatter plot and look for D values that have large gaps when compared to the rest of the data. That's what we did when we did the scatter plot. We just looked to see if there were large gaps. And we can request, and so this is the scatter plot you'd make, where this is just the case ID number on the x-axis, and then this is the value of the Cook's D. And you would just look for large gaps. I don't know, are there large gaps here? Are there large gaps there? Sort of, maybe, but it's not horrible, right? And remember that this is just an ID number, so it's utterly meaningless. It's just a way to spread them horizontally. It just seems like there's sort of a progression that goes from here, and then we jump a little bit higher to here. And there's a little bit of a jump to here, and then not much of a jump to the next one. I wouldn't be too alerted, but let's say we had none of these in the middle right here, and we just had those two at the top. That would be like, oh, there's a big gap there. There's something strange going on. I want to look at that really carefully, and that's what I'm thinking about. We're talking about in terms of gap. And so just to make it concrete. In SPSS, for your analysis that you did last week, you would just rerun that analysis. You would just rerun that analysis, and you would say under save, I don't want the residuals. I want it just to say Cook's distance. say continue, and say OK. And it saved that variable to that data file. And then if I go back to my data file, this is the Cook score that it calculated. Why are some of these null? Why didn't it calculate a Cook's D for all of these people?
Missing data.
Right, so it list-wise deletes people, and these people were missing, everybody where it didn't calculate a Cook's D, they were missing some data. They were missing some data in the data. Some data in our in the variables that we had in the analysis. And so just one other, while we're doing it, so I have this case ID variable here, but let's say I didn't have it. Maybe you don't have that in your data set. So I just got rid of it. There's a function, we can do transform, compute. I don't remember what it's called, but it's something about case num, that's it. And so if you read what case num does, it just gives a sequence number for each of your cases. And I can just call this whatever I want to. And it's going to create a new variable in my data set that will be that same thing that I just deleted. So I have this new variable that is 1 through whatever the number of people I have in my data set. So if you don't have a case ID number, that's just that's easier than doing this, right? The other thing to do is you could do 1 and 2 and 3 and 4 and 5. Or you could just use that function, right? And so I'll let you choose. And so we're going to do a graph. And I've never used anything other than the legacy graphs in SPSS, so I don't even know what all of the great magic is with the latest and greatest. And so we're going to do a scatter plot, and just a simple scatter plot. And then I'm going to just reset this. And so the y-axis and the vertical axis, I want to put the Cook's D. And then horizontally, I want to use the case ID number. And that's really all I need to do. This is shaped kind of funny because remember I sorted it by residual earlier. And so that's why it's sort of shaped sort of weird, because I put all of the high residuals first, and then I put all of the low residuals and low residuals first, and then the high residuals. And so that's why this looks kind of funny, because that case ID number had that sorting that it used. But the same would apply. I would look to see are there gaps, and it's the same data, right? And we might differ on whether there's a gap between this point and this point. It's probably worth looking at these, in this case, these two individuals to see if there's anything unique about their data. And again, you can double click on the graph, open up the editor, right click on the graph, and you can say add, show the data label, or easier, just go to the case in the data set. And we could go back and look to see, well, what makes this person unique? This person attends church 7, so they attend church a lot. They pray a lot. They, what is this, they have low affiliation with their religion. So they attend church a lot, they pray a lot, but their strength of affiliation, so they're like a Catholic and they don't feel like they're Catholic, but they go to Catholic church a lot and they pray a lot, right? That's because this is a really low number, and so that's probably, they believe in life after death, income is low, 87 is high age, so that could also be leading to some of the uniqueness of this person. Education is high, and so again, I would ask the question of myself: if somebody else replicated my study, would they find somebody that's equally as extreme? And I think clearly you would, that there are people who, again, I probably know people that look like this. And sorry, you can't read that very well on the screen. So that's what we would do to identify influential cases. This is the same person that we were just looking at. So, questions about Cook's D or identifying influential cases? I think when you look at your data, you'll be able to make the determination pretty quickly, is this a problem or not? And so then the last thing that I have for regression, boy, it seems like we've been talking about regression for a long time, doesn't it? The last thing I have is just maybe how you might think about writing it up. And this is just how I would write it up. And I ask you to do a write-up for homework number 3. Thank you. And this is how I would report it. And the maybe just and this is those of you that are APA sticklers, which I never have been. I think this is APA, or at least it was APA the last time I used the manual. What version? What?
Version 6 right now.
Yeah.
It's
switched in like 2010
oh, so I think I was on that edition when.
when it changed from 5 to 6 in like 2009.
Yeah, I think I was still in the department and probably was mad when they changed because I.
They made so many mistakes.
Oh, in the 5th.
In the 6th, when
Oh.
they first published it, then they had to like send, there was a lot of mistakes within the APA manual. Ironically. APA mistakes on APA.
And so just a couple things that so P for sure has to be italicized. So you should italicize P's, right? Greek letters I don't think are italicized. Yes? No way. Show it to me. Are you sure? We italicize Greek letters?
No, we don't. No.
Don't italicize your Greek letters, but italicize B. And so in this case, I'm reporting my B's in the text of the in the text, and so they're all italicized. And the P value that's associated with the B is also the P is italicized. The less than sign isn't italicized, and the 0.001 is not italicized.
So it's in the last week when you talked about reporting B and not beta. You were talking about an actual write-up and reporting, not necessarily in the chart.
Yeah, and I'd let you decide. In my case, I always report B here, but I also report beta here.
Okay.
Somebody else, for whatever reason, might decide to report beta up here, but then at least in the table, give the reader both B and beta. And then I'm reporting the R square, any statistical symbol. Is R square a statistical symbol? Is that what we call that? Has to be italicized, right? So R square is italicized.
This table, you don't want it to have the p-values?
So I use the asterisks to represent the p-values.
The t?
Oh, the t. You could put the t's in there if you wanted to.
Okay, the same table?
I could calculate the t pretty easily if I wanted to, right? How could I use this table to calculate the t's?
B divided by standard error.
It gives you the t, right? So if the user really was mad that I didn't give them the t, they could just write it in the margin of the table if they thought that it was useful. Or if you really wanted to report the t, you could report the t. And then you could do another column for I use the asterisks, which I think is a fairly common way to do it. Other people might have another column in there where you'd actually have the probability. and you could report the probability. I do like, I don't think we do it very much, but I kind of like the idea of like this first B that I report, or when I do the R square, I report, what do I say? I say we explain 36.3% of the variance of our dependent variable. And then this is the F test below here, right? And where does the F test come from? It comes from the ANOVA table in the output that you get, right? So that you have to make sure that you get that. But I like the idea, what I was saying is I like the idea of instead of doing P is less than 0.001 or P is less than 0.05, I think there's some value in saying P is equal to and then reporting P that you get, assuming it isn't use exponential notation. If it's 0.000000001, don't report that in the text. You could just use some shorthand to report that. But so just that would not be a common way to report statistics. But if you decided you wanted to do that, I wouldn't hold that against you. I wouldn't give you extra points for doing that either. But I just think it's useful because it's not less than, what's less than 0.05? Well, that could be, we know it's not 0, but there's a lot of distance between 0.05 and something that approaches 0. And so it's just more information that really doesn't have a lot of cost associated with providing your reader with that information. So any questions on reporting? So I would look for yours to be about this long. Don't give me 5 pages. You don't need to give me a primer on the theory. Just give me the facts. And this would be, what section would this be in? If you're writing a journal article?
Results.
Yeah, you'd put this in the results section, right? So it's just going to be that little bit of, you'll already have covered all of the stuff about the theory and all of those other important pieces of information prior to. Make sense? Questions about homework 2 or 3? Questions about homework 3? When's it due? Yeah, I have to remember to put a folder up. Sorry, I didn't put a folder up until
3:30 a.m.
Oh yeah, I did. No, I put it up like it was like at 8 o'clock last night when I went to bed. To be honest, and I get up at 3:30. But then I got an email. Was it from you, Natalie, saying I still can't? I forgot to publish it. Right? It's the
Yeah,
Go-
you have to push the little green cloud.
yeah. Why doesn't auto? It should just publish by default, right? So I published it at 3:30, and hopefully I'll remember. But I appreciate somebody sending me a nice email. Asking me where it's at. So that's homework 3. Next week we're going to talk about factor analysis, principal components analysis to be precise. So we have time to talk about one of 3 topics. We can talk about hierarchical multiple regression. We can talk about nonlinear regression or predictor selection methods. I think the topic that I want to talk about, unless somebody is opposed to it, I want to talk about nonlinear regression. And then we can test. William had a hypothesis for us last week with income and church attendance. I don't know what your hypothesis was, but you didn't think it was linear, right? And there's a debate about whether it's...
Natalie and I have competing hypotheses.
Okay, so we'll test whether either of those, because we know that income is a predictor of whether, as income increases, were they more or less likely to attend church?
There's not significant.
Really?
My
I thought it was. Let me look.
hypothesis was low income and high income would most likely go to church.
And what yours was in
And
the
the
middle.
people in the middle were like average.
So
Oh, no.
income, right? So income income is, as income increases, they're more likely to attend church. And it is significant. But that doesn't mean it can't be that doesn't mean it can't be nonlinear too. It might be we're just capturing part of that relationship potentially. So we'll talk about that, and we'll go back and we'll test that hypothesis before we're all done today. So let me get to in the slides where we talk about nonlinear regression. So curvilinear regression uses the same regression format as we've already discussed. The only change is that we transform our independent variable, or variables in some cases. And as you know, the equation for a straight line takes the form of y is equal to some intercept times b times x is the equation for a straight line, right? And a first degree polynomial would have an exponent involved, or a second degree polynomial or quadratic analysis would have one of your independent variables raised to the second power. And the equation for a line would be, that's probably not how you teach sixth graders how to write the line. Didn't we always start with x squared plus x plus constant, right? That's the way that, but the way that I write it here anyway is that sort of in the same format that we've looked at regression all along, where we have some constant, and then we have b times some value for b, and then we have b2 times x squared. And we could also do a third degree polynomial. So quadratic is either a u or sort of an inverted u, and cubic would be some weird looking s, probably sideways s is how it would look. And so we could test actually we could test both of these with our data, and we just keep these equations in mind as we start looking at the data. But just a couple things to consider. In the social sciences, anyway, we probably wouldn't do anything. I don't even know what a fourth degree polynomial looks like, but we certainly don't have a theory that would predict that, right? I don't even know that we have theory that predicts nonlinear relationships that much. And so we might have a few theories that predict, and like the theory that we have with income and religious, that theory it seems somewhat intuitive, but we probably need to be really careful if we're testing polynomials that are greater than third degree. So using the raising something to the fourth power or raising something to the fifth power. And essentially, if you mind, and then this is actually a technique that we use for data mining, is we create polynomials. I don't know that I've ever done it out to 99, but we certainly do. We certainly go beyond the third. But our approach is different. We're not testing theory. We're trying to maximize a prediction, which isn't what you're trying to do when you're testing theory. The two are different in many ways. So we'll talk a little bit about how we would test a second degree and third degree polynomial. And we do that by just doing ordinary regression analysis, except for that we create these new transform columns that are included in the analysis. And we include them, I think there's probably debate about this, but sort of the traditional way of including them is we put them in a separate block by themselves. At the end of the day, putting them in a separate block by themselves probably doesn't get us that much, but I'll show you what that means and how that looks in just a minute. And so essentially what we do is we do an analysis in these sequence of blocks, beginning with the first degree polynomial, followed by the sequentially higher degrees. And then what we're assessing is our R square for each of the blocks. And if the R square is significant, if the change in R square is significant, we have evidence to indicate that there's a nonlinear relationship between the independent variable and the dependent variable. And so this is some fake data that I made up that you can tell just this graph is just data never looks this good. And so you can tell that I made it up. But we're going to not use that fake data. We're actually we'll use the data that we've used for the homework or for the class example. And so I just need to get SPSS. We can all take a coffee break while SPSS is opening up on my computer. Even though it's a new computer, it is really, really slow. Oh, here it comes. If I change, I don't want to mirror them. I want to have extended screen. I don't know, does that make it better or worse? I guess we can see it slightly better. So if I find my data that we had, and so we think it's income, right? We think there's a nonlinear, we want to test whether there's a nonlinear relationship between income and our outcome, which is whether they attend church or not. But we also want to keep all of the other variables in the analysis. So our equation is going to be everything that we've had to this point, and we want to include the polynomial, second degree polynomial for income. And we don't have any reason to believe that it might be a third degree, right? We don't think it's going to be a sideways S thing. That would be like a data mining thing if we were going to do that. We just think it's going to either be U or inverted U, right?
Right.
U would be low income attends church a lot, and high income attends church a lot. The middle income stays away from church. Inverted U would be middle income attends church a lot, and the two extremes, low income and high income, don't attend church as much. And they both seem, I mean, you can make arguments for either one of them, right? But argument absent data is just talk, right? And so we can assess that. And so what we need to do is we need to transform. We're going to compute a new variable, and we're going to just do income square. I wouldn't put an R there because for me that would be square root. What would be another way? I don't like SQ either. Could we just do income 2?
Wait, was it it's income square root, you said?
It's not square root, it's squared.
Squared.
Right, and so what would we, I could just do SQ. If I do SQR, that means square root, right? How would I abbreviate it?
What about you?
It was
SQ.
you.
Do what?
You could
SQRD.
SQRD.
I like that.
SQRD, squared? Yeah, okay, I like that.
I'm sitting here like, why
Good.
don't we just spell it out?
Why don't we what?
Why don't we just spell it out?
Just take out-
Well, you could, yeah, but then, yeah. Yeah.
Or exponentially.
Yeah, we could just spell it out, yeah.
I'm struggling to come up with something.
And so then it's just income. And then SPSS uses this notation to do square root. And if you want to do cubed, it would be that. And if you'd want to raise it to the 4th power, it would be that. There would be some other ways to do it, but this would be the most common way to do it. And so now it created a new variable that that is income squared. And so it's just the square of that vector of data for everybody. And so then I include that variable in our analysis. And by the way, is there a correlation between squared income and income?
Yes.
Oh, yeah.
Yeah, and so it always, you just need to be concerned about multicollinearity. And in some cases, there's some other tricks that you can do. There's some other tricks that you can do that we're not going to do here that could reduce the collinearity, potentially. And so if you ever run an analysis like this and you have problems with collinearity, and I don't know if we will here or not. Again, there's some tricks that we can run. So we're going to just redo our analysis that we had before. We're just going to add that extra variable in. So our dependent variable is whether they attend church or not. And then we're going to do pray all the way down to education. And we're going to put those all in the first block. And then if we do this next, we have block 2 of 2. And these blocks are just a way to separate variables in the analysis. And so what SPSS will do is it will run all of the variables in the first block by themselves. And then it will add in the second block of variables to the first block, and it will run that in a separate analysis. It doesn't run block 2 of 2 all by itself. It just adds those on to the variables that are in block 1 of 2. And so in block 2 of 2, we're going to put in our income squared. And then I'm going to say statistics. And of course, we want descriptives and we want collinearity diagnostics. But then the other thing that we want to get is we want to get R squared change, which would be the change. Is the R squared increase from block 1 to block 2 significant or not? That's what the R squared change will give us. In other words, does adding income squared make a meaningful contribution to our overall R squared? And that's what this will test for us. Because if it doesn't make a meaningful contribution, then of course the relationship is not quadratic anyway. And so then I can just say run, and we're going to have some output here. Where'd that minimize window go? See that window? I want that window. Again, oh, there it is. Somebody help. It's there. Why is it minimized anyway?
Oh, mine's been doing that too.
I know. We need to.
You have to like drag it out.
It's probably the most expensive software that you'll use in your college career, and it's also probably the. Why doesn't that?
Oh, no, I've never.
Just change
It lets
it.
me drag mine, resize the box, but it just makes it small.
I swear.
And so.
If you could click scale, there it goes. There it goes.
What were we gonna say? To do what?
I was gonna say if you click scaled, it might. I was wondering if that would
That makes that sort of scales both of them.
be bigger. I don't know because it's just. I think it's because it's. You have a retina screen.
Yeah.
I think it's putting the retina screen is not as pixels in the projector to mirror it.
So what's the correlation between, just for the heck of it, the correlation between income squared and income is 0.979?
Almost one.
That's high, isn't it?
Yeah.
And so we have to be, let's sort of look to see what we have here. And so this is our R square for block 1 variables, which would be everything that we did in the original analysis, is 0.363, which should be exactly the same as I reported earlier. And then the R square after we added in the square of income goes up 1/1000th. And the F is not significant. But I worry about do we have any collinearity problems? So this is tolerance. And
For less than 0.1.
what are we looking for?
So that bottom one and that other, the inverse.
So this one was a 0.4. Is that a problem? And 0.41 is a problem? Yeah, so we have 5 minutes. So the fix would be, I think the fix would be, we want to reduce the collinearity. And so I think we can do, let me just try. If I just do data, because that's not a very good test. If we lived with that test, it would neither of the hypotheses are correct. But because it's so high, because the correlation is so high, I think that's going to be a problem. But I want to just because we've gotten this far, it's hard to turn back. We're going to do descriptives, and I'm going to do descriptives, and I'm going to take my income variable and my income squared. I'm going to save standardized values, and then I'm going to rerun my analysis with those standardized scores. Or at least I'm going to do this and see if that helps. Because I just standardized the square root, or the square. And the correlations, yeah, and so the fix would be actually, instead of taking the standardized, the fix would be you center you center the independent variable around 0, sort of like we did in the numerator of that ratio. And that should reduce this correlation. And then that would be a better test for us. But to do that would get us in the weeds more than I want to get in the weeds now.
I'm sorry. So just to, if you wanted to just see before you did all this, if maybe it would be right. Could you just do a scatter plot? I know I wouldn't tell you if it's significant or not, but you could see like if there was any trends.
Yeah. So the scatter plot, my guess is going to look really ugly, but let's do that just to. And so graphic legacy graphs, and we're going to do a scatter plot, and we're going to do simple scatter plot. And I want to do the dependent variable on the y-axis, which I'm not sure why we can't see it. It has something to do with my resolution. And then I'm going to do the square. No, I want to do the original. I want to do the original income here. Yeah, because the income is on a 1 to 7 scale, and religious service attendance is on 1 to 8. Things just line up.
So
It'd
be easier if they were actually continuous instead of discrete variables.
Yeah, and there'd be a couple fixes. You could add just a random amount of noise and we call that jitter, Jitter. We could jitter the data, which would be just adding a random amount of noise to everybody's score. That would get them so they wouldn't be on top of each other, because they're all just stacked up on, all of the points are just stacked up on top of each other. But if you jitter them, they wouldn't be stacked up, and it's just random noise, and you might be able to see some kind of pattern. My guess is the pattern would be so subtle that we wouldn't be able to detect it by looking at it. We might be able to detect it with a regression analysis, and that's been my experience, where it's rare that you see something that looks like a U or an invert. The data just never seems to be. There's just more going on with the data than just that nice U or inverted U. So other questions? So since the break, what did we do since the break? We did the influential cases, right? And so everybody's good with that. Cook's D, put them on a scatter plot. And then, see if there's big gaps. Then everything that we've done since then is, if you feel like just forgetting about it, you can forget about it. If it's something that was useful and you want to talk about more, we can talk about more. I am sort of curious about the income thing. I'll fix the analysis so we can run it, and then I'll bring the results back for next week. And so we have and I'll let you know how I fixed it. It's just a matter of centering the independent variables, but I'm a little bit, I don't want to take time to do it now, but I'll do it for next week. And we'll talk about it at the start of class next week. And then we're going to talk about principal components analysis, which your textbook is a good resource for principal components analysis. And we'll take our time and walk through how to do that step by step next week. All right? See you then.
Okay.
Thank you.
So I have to do mine. For my teach, I have to do scale and then 1280.
And do 1280.
Because it'll make it bigger. It's because if you have a retina screen, it tries to put the retina screen on there, and there's not enough pixels on the projector to do it. So
that's somewhat readable. That's more readable than what I had, right? Yeah, good. So I'll just remember to do that, and thank you. And so this is they're both the same resolution.
No, it's because this is on. It's because your retina screen is technically it's not like the 1280. It's actually like almost like a 4K.
Okay.
So it's like putting a 4K TV, but this can't handle 4K.
Right.
Like,
Okay. Good.
so that's
Good.
why it messes it up.
Thanks.
Good.
Oh yeah, girl, of course, it's only
Wanna
charged
change
everything,
that a
don't
little
worry.
You're good. Let me shut this recording off quick so I don't forget.